New topic. Again, I'm Dante on convergence. We're going to talk about IPC right now, which is InterPlanetary consensus. It is basically a newer attempt to scale Filecoin, to scale really any blockchain horizontally, which, usually when people talk about the horizontal scaling, they're talking about like microservices. Which we'll talk about some of the issues involved in that too. But this is a really cool project. I got to talk to this team this last week. Again, this is IPC. You can watch this video quick. It's really quick.
Storage is rapidly becoming an element of critical infrastructure for Web3. In the years ahead, it will provide a backbone for the growth of the new meta economy. With the launch of the Filecoin VM, developers will have a firm foundation on which to build storage-intensive applications in decentralized computing, GameFi, the metaverse, DeFi, and beyond. For many, however, scalability remains a roadblock. As a chain gains users, it becomes the victim of its own success. Transactions are delayed, fees increase, and the user experience suffers. So how can a blockchain achieve escape velocity? Horizontal scaling. The main bottleneck to scalability is the consensus layer, and InterPlanetary consensus provides the solution. IPC avoids the limitations of traditional sharding strategies. Instead of partitioning state, IPC introduces subnets, which applications can create at will and use to execute transactions. Each subnet can execute transactions in parallel and customize its own consensus algorithm. And further subnets can be deployed as needed, creating a hierarchy. By checkpointing state with regards against malicious transactions. Furthermore, subnets can interact horizontally with one another in the system. This flexibility means IPC subnets can be molded to resemble various L2 platforms. In addition to the ability to compute and coordinate, IPC also offers other unique benefits. Smaller sets of validators in proximity can attain much lower latency. And partition tolerance means that functionality is maintained, even with connectivity constraints. In short, InterPlanetary consensus offers performance, configurability, security, and scalability. With the power of IPC, the future is yours to build. Head to ipc.space to learn more and launch your next decentralized application.
How is this different to what Polkadot is doing? So Polkadot's a sidechain. This has similar kind of use cases, but on IPC you could actually implement multiple consensus algorithms. So you're not bound by, like if you wanted to spawn your own Polkadot sidechain, you can do that, but you're still bound by the Polkadot consensus protocol, right? So on this, you could actually spawn, I'll show you.
So you're saying it's more scalable?
It is, yeah. Well, it's more dynamic, yeah.
More usable?
Yeah, there's a lot of benefits to it.
What's the difference between this and LibP? Is this just like a bigger version of LibP?
No, LibP2P is a peer-to-peer networking protocol. This is the
Consensus protocol.
consensus protocol. During transactions constitute significant scalability bottlenecks standing in the way of massive adoption. All participants need to replicate, execute sequentially every single transaction. There are 2 protocols in resolving this scalability limitation. So they present interplanetary consensus. It enhances the scaling capabilities of L2 plus protocols. Users of IPC can dynamically spawn new blockchain subsystems, subnets, as children of any existing subnet. IPC is based on the design principles of on-demand horizontal scaling. Child subnets leverage the security of their parent subnets by periodically checkpointing their state in the parent state. And yeah, they believe this addresses several issues with existing L2 approaches. including limited throughput capacity, isolation from each other, centralized components, and monolithic architecture. So and there's a lot more on their GitHub.
The name, look, the child subnet's based on Trantor.
Yeah, yeah. So that's really interesting. So if we look at their website again, Mir and Trantor, they actually, I believe they're involved in the writing of Mir and Trantor also. So Trantor is a really cool system. Again, the problem Trantor solves is total order broadcast, and formally in a system consisting of multiple nodes. Each node receives client transactions and output batches such that the sequence of transaction batches output by each node is the same. Actually, Mir is something that we probably have interacted with in some way. So Mir is a distributed protocol implementation framework. Let's see. Yeah, basically, so there are a bunch of use cases here, like peer-to-peer chat, and any kind of distributed consensus protocol, like CRDT based, where you're trying to become eventually consistent on state. All the nodes eventually merge on state. This is a framework that you can implement to kind of give you that. So yeah, again, distributed networks, and those are the two main packages that IPC is built on. And then going back here, yeah, so again, I talked to these guys this week, and if I go to my notes, I've got my AI overlord recorded this, so I'm gonna let you guys just kind of hear it from them, kind of what the IPC team thinks, or how they describe this.
I mean, we can talk about the architecture now. Do you want to do it, Alfonso?
Yeah, I'll take this one. So in the end, subnets need to, the key infrastructure for a subnet is the following. You get an IPC agent, which is the one that orchestrates the communication between the different, so applications in the end interact with the IPC agent, which is the one that under the hood interacts with the underlying peers for the subnets that you're interacting with. And if you have a single subnet, your agent will be connected to at least two networks, the parent and the child subnet, right? So if you're in Filecoin mainnet and you want to deploy a new subnet, what you do is that you deploy a set of smart contracts in the Filecoin mainnet, and then you spawn your sidechain, and your agent handles all of the back and forth. All of the information that it pulls information from mainnet and push it into the subnet and the other way around to get the communication. So in terms of hardware requirements, it really depends on how big you want your subnet, right? Because you could have one peer subnet where you would need, you could have just your IPC agent and your subnet peer, and then have the IPC agent interact with Filecoin mainnet directly through Belief, for instance. And the kind of requirements that you would expect is a Lotus full node. So at this point, without any storage specific features. So it's a few gigabytes and not much storage, depending on how big your chain grows.
Sure. Awesome. Yeah, it's really interesting. So I think, and so obviously, one of the biggest benefits I think that draws people to this is low or zero, or close to zero transaction fees. Is it similar to like a Lightning network in that once there's a settlement on chain, there's gas and fees associated at that point, or yeah, do you guys have that?
So this is a bit more flexible in the sense that you can configure it as you wish. I mean, you can configure, you have some level of flexibility to configure your subnet. How it works right now is that when you want to spawn a subnet, you put some, I mean, we require some minimum collateral, but like this is just a threshold. We haven't figured out the crypto icon. And when you want to inject something in your subnet, you have to stake in Filecoin mainnet that amount of funds that you want to have as a circulating supply in your subnet. With this, your subnet, like right now we have a consensus that could run, its instant finality is based on a BFT protocol and has like block times of 1 second, which means that you could transact as much as you want and like execute smart contracts in that subnet. And then when you have some balance and you want to like exit the subnet, so you have some circulating supply in the subnet and you want to send it to Filecoin mainnet, you do a specific transaction that would allow you to do the settlement as you would see it in a layer 2 or in a bridge where you get your funds back. You would only be paying fees for Filecoin mainnet in the way down. So when you stake some funds to have it as circulating supply in your subnet, and in your way up when you move some funds out of the subnet. That's kind of the only 2 interactions with mainnet.
Right. Nice. Yeah, that is really cool.
And then in subnets, you could do whatever reward system you want. So right now, I mean, the default is that rewards fees in the subnet go to the validators. So if you're a validator, they are proportionally and fairly divided between all the validators, but we're working on allowing anyone to fine tune whatever gas model they want.
Sure. Right. Yeah. That's one of the really cool aspects. I mean, one of the use cases that we're thinking of is, again, the application I showed you is kind of like a peer-to-peer YouTube without the YouTube. If you have the beauty of giving every end user their own nodes or multiple nodes, is that, you can, like, you're basically distributing the cost of the bandwidth and everything associated with that, like the hosting of the system, distributing it equally. When you want to scale the network, it scales minimum 1 to 1, sometimes 2 to 1 with the number of users and the number of nodes. So you pretty much always have enough resources. And I could imagine like kind of like a distributed like an Amazon kind of a thing, like let's say it's called a subnet that is geared for like e-commerce that uses a consensus algorithm that everybody is comfortable transacting with, and or like maybe has some kind of standard that sellers need to meet, right? And it would basically run its own consensus. And so when you want to transact, you can, we can actually enable consumers to contribute validator resources if they want to interact in that market, right? And that's, I think, is one use case that we're looking at. Love to hear if we're on the right track.
I mean, I think that's really cool because it actually matches the kind of use cases that we were hoping to have with IPC. So have different subset of users that have their own infrastructure, and maybe they can share costs on this infrastructure and so on.
Yes, right. Yeah.
Yeah, and to your point on wolf fees, there is also, I mean, that can also leverage the hierarchical aspect, right? Which is like you could have a subnet, so you need to pay checkpointing fees anyway, right? But you could have a subnet for Cloud Forest as a whole, and then have other subnets for users that would checkpoint onto the Cloud Forest one, right? So you could basically have already a high throughput, low cost layer where everyone else would where everyone, yeah, to which everyone else would connect, and then you would just have to checkpoint the aggregates up. So yeah, so it should be it could provide very good strategies for maintaining the transaction pricing basically near zero, as you said. Well, obviously with the caveat that, well, the caveat is that the validators cost money to run, right? So someone has to run them, and if they're not incentivized by fees, not, I mean the subnet validators, right? Then they're a cost that needs to be managed elsewhere, right? So if it's the person, yeah.
Yeah, and that's what's kind of beautiful about this system with when you think about consumers, because we're already charging the consumers to run these nodes, you know, kind of like, you know, working with Picnic, we think we can get the price down close to like what you would pay for like a Spotify or Netflix. And if we can do that, then, you know, you're already paying for this, you know, kind of content platform. But you can use that same infrastructure to, you know, basically, you know, like cut your transaction fees down when you're shopping. And also for the sellers on that system, or the content creators on that system, you know, right now, Amazon, eBay, they take, you know, close to 20% of every sale. YouTube takes like 80 to 90% of all the, you know, ad revenue.
Yeah.
And that's because, you know, that's because they host,
yeah, of course,
know, the 4K video, you know, bandwidth, but, you know, their margins are unbelievable on that, you know. So if you could have, you know, if you can get consumers to pay that $9.99 a month on this kind of system, you can have a peer-to-peer system that, you know, feels and acts the same, but the content creators, the, you know, small business owners are keeping way more of those profits, and, you know, it's just a like way healthier ecosystem. And everyone controls their data, you know, owns their data. So
yep.
Again, basically, you have some Filecoin FEM smart contracts. You've got this IPC agent that you basically download from their GitHub and you spin it up. Again, you probably need at least like 4 core, you know, 8 gig of RAM to run it. Nothing too crazy. And then it spawns this root subnet, and below this root subnet, you can have as many subnets, other subnets as you want. And again, these can have different consensus protocols in them. So if you wanted to create like a Web3 game or something, you could basically spawn a new subnet off of Filecoin, have, you know, issue your own token, right, with your own consensus algorithm. All of the actions or the transactions that happen in that subnet can stay in that subnet as long as they need to. You can even have multiple subnets, multiple chains. So if you have like in your game, maybe you have like NFT like items people can win, then maybe you have like some, you know, token that you need to pay for your hosting or something, or maybe you maybe every one of your users is able to spawn their own tokens, right? So you can have these kind of multiple subnets, and they can actually all communicate with each other. That's a big benefit of IPC. And you can, you know, layer these on top of each other. And if you look here, this is kind of the network. So basically, it's a little bit tough to see, but these are validator nodes. Every subnet has to have its own validator nodes. It's kind of like, you know, your miners, essentially. You know, there has to be somebody in the network that is incentivized to validate the consensus on your network. And they kind of leave that incentive model to you, so you can pick and choose what, you know, what your incentive model would be for those validator nodes. And you can also have smart contracts on those subnets. So again, you can spin up your own network, you can spin up your own blockchains, essentially. Everything going on down here will settle onto my root subnet, so it won't bubble up to the parent chain unless you issue an action, like a settlement action. So you could run your own subnet for years essentially without settling up on the parent chain without blocking resources on that parent chain. And again, if you wanted to basically shard this, you can do it horizontally so that like maybe this room for this this meetup, we spawn our own subnet so that if we want to do transactions in this room, we could do that. Maybe because we have enough validators in this room, we have enough space on the network. Maybe those transactions have 0 transaction fees.
When do you pay?
So you pay when you spawn the network, right? So you have to lock up. Basically, you're doing a smart contract on FVM and locking up some initial value, and then you can utilize that value on the lower level to act as liquidity for your system.
Are you constricted to a certain language? Yeah, probably.
Yeah, well, a lot of these systems, Lotus, a lot of the IPFS systems are using Go in terms of implementation. I think Rust too now, a lot of them, they're starting to build support for a lot more.
But yeah, you probably can do more than enough with Go.
Go, yeah, Go's great.
And you're only paying when you're spawning up and you connecting to the chain again?
Correct, yes. Yeah,
So,
there will, if there's a negative balance, once you settle up, you'll have to reconcile that as part of the smart contract. So the smart contract won't.
what's an average amount?
Man, that's a great question. So right now, right now, this is not live on mainnet. They are using it. Well, they're using it on the Filecoin chain, I think, to scale FVM. Like, you can actually run FVM in one of these subnets, and because FVM uses WASM to execute your compute, whatever your script is. That execution can happen down here, and it never has to touch the parent chain. So again, gets rid of that backlog. Besides them using it internally, it's only available on SpaceNet right now. So you can, go to the Filecoin faucet and grab a bunch of coins and play around with it. So that's probably the best way to kind of figure out, how much funds you need to lock up. So kind of do what you're trying to do. It really depends on your use case. Yeah. So again, the dangers in kind of like the serverless architecture is that you still need servers. So if you're saying, okay, like just go serverless, why would you do that? Because you're not paying for servers to be running 24/7, right? But somebody is, right? So how do you square that? Who's responsible then? It kind of goes back to the counterparty thing. It's like, okay, we just trust these processes to like this third party that's running all the infrastructure for this, then we're bound by, if they want to block that content on that infrastructure, like they can do that. So yeah, again, trade-offs. You gotta look at, is it worth it to run my own? Or, again, with these, if you're running a subnet, and the subnet has incentive for validation, like maybe you become a validator, and you can like reap rewards for doing that. And that adds to the decentralization of the network. And so there should be incentives for people to run the servers that these systems need, right? And so that's, again, that part, the IPC team kind of leads up to whoever's implementing it. You have to figure out how you're going to incentivize the validators of your consensus protocol to actually be validators and to stand up that hardware. And that's a challenge. So again, that's something my company is looking at.